All right, guys, we are going to talk about graphing polynomials. Now, I'm probably going to refer a lot to our previous set of notes because we talked about this a little bit here. But in our notebook on the next 2 pages, you guys should have this one here, this little sheet that takes us through step by step how to graph. And then we're just going to try a whole bunch together. Okay, so this is a slow process. So let's kind of walk through the things over here really quickly first. Let me get some color in here. I need some color up in here. Okay, so first thing we want to do, as long as we are in factored form, maybe we should make that note. Factored form, we can graph. If we're in standard form, we don't have a way yet, but if we're in factored form, we can do this. So the first thing you want to do is find and plot those zeros. Now remember, zeros is just a fancy word for your x-intercepts. Remember, we can just find those by looking inside parentheses and taking the opposite number. If you don't see one, then it's 0. Okay? The second thing we wanted to do was find the multiplicity. Now, multiplicity was just this fancy word for cross, wiggle, bounce. And so whenever we had a multiplicity of 2 or an even thing, that was a bounce. And whenever we had a multiplicity of 3 or an odd thing, we would wiggle. There's a little bit of a goof up here. Even multiplicities bounce. Odd multiplicities cross. JK, 1. No multiplicity. 1 exponent. Cross through the x-axis. So anything else that's odd will wiggle, but a 1 crosses straight through. Now the next part here is we have to think about our end behavior. So this is all of our end behavior stuff. And when we think about our end behavior, A is that leading coefficient. Like, are we positive or negative? Don't worry about all this limit stuff. That's some pre-calc stuff. If you want to cross it out because it's scary, you can. But also you have to add all exponents to see if even or odd. And then kind of the last thing, you want to start from your end behavior and graph backwards through or bouncing off your zeros or your x-intercepts based on your multiplicities. Now again, we talked about all this stuff on the last page too, so I'm going to kind of be referring to that as we graph some of these. So let's just dive right in. Let's say we have, I'm going to put it at the top here, graph. Oh my gosh. My goodness, graph slow, write slow, think about your words, come on, jeez. For example, let's say we had the function f of x equals negative x squared, parenthesis, x plus 2. Okay, so first we want to find and plot our x-intercepts. So let's kind of get a little x and y axis going. And let's find some stuff over here. So we got our x-intercepts. The first one that I notice is 0 because there is no number being added or subtracted. The next one that I notice is a negative 2 because inside parentheses we're going to take on the opposite thing. Then we can go plot those. So the only spots on my graph that I'm going to be allowed to touch the x-axis are at 0 and also at negative 2. You are not allowed to touch this line anywhere else. Those are the only 2 spots that they touch. Okay. And the next thing we want to think about is multiplicity. So 0 has a multiplicity of 2, which means that we bounce. And negative 2 has no multiplicity because it has an exponent of 1, which means that we cross. okay? Next thing that we need to think about is the end behavior. Okay, so when I think about the end behavior, I think about my cloud. I'm going to also practice writing it in correct notation, although for graphing purposes, it's not super necessary. But for my cloud, I need to add up all my exponents, so 2 and 1 to get 3, so we are odd. And then I also need to look at the leading coefficient, which is negative. So odd like a line and a negative sloping line is going to look like this. Okay, so that would be x goes to negative infinity, x goes to positive infinity, and when we're negative, y is going up, and when we're positive, y is going down. Okay, let's graph. We got graph slow. I just want white out. Graph slow. So we're going to start with our end behavior up here. And I kind of have to start past my first x-intercept a little bit because like I'm going to have to work my way down to it. And when I get to the -2, I'm going to cross right through because that's what that one does. Oh my gosh, I hate that I'm doing this in pen. Ah! Now the thing is, I have to get back up to this one. So I'm going to have to like turn around now and do like a little hump down here. And when I get to the 0, it has a multiplicity of 2, so I'm going to have to bounce off it. So I'm going to have to do like a little baby parabola off this. And then come right back down. I have no more spots that I can touch, so I just have to end going down, which is what I was supposed to do. Let's try again. Let's try another. Okay, scooching that one up. Let's do, I'm going to grab the homework here so I can see how I wrote this. Okay, let's say we have x plus 3, parenthesis x minus 3. Nope, JK, 1 to the 3rd. That's what I want to do. Okay, let's get our x and y axis going. And then let's think about the things. Okay, so the first thing that I want to think about are our zeros, aka our x-intercepts. So the first one that I see is -3, and it has an exponent of 1, meaning that it will cross. The next one that I see is x equals 1. That one has multiplicity of 3, meaning that it will wiggle. Okay, so I can go plot those points. So we're going to touch the x-axis at -3 and 1 and nowhere else. Those are the only 2 spots because those are the only x-intercepts. The next thing I want to think about is my end behavior. And this time I'm just going to draw the cloud because I want to do more examples with you. And I don't want this to be a forever video. So if I think about my end behavior here, if I add up all the exponents, we got 3, 1, so 4. So we're even. Leading coefficient is positive. So even like a parabola and a pointing up parabola. So my end should look like this. So when I go to start my graph now, I'm going to start up and a little bit past that first x-intercept. So kind of here-ish. And when I get to the -3, I'm going to have to cross right through it. So boop. The trouble is I have to get back up to the 1. So I'm going to have to do like a little hump down here, like a little turnaround. And when I get to the 1, I'm going to have to do a wiggle. So like I'm a confused parabola. I kind of want to do this parabola, but then I change my mind. And so I end up going up. And I'm not going to come back down because there are no other x-intercepts and I was supposed to end up, so it all worked out. Heck yeah. Now I know I'm going kind of fast graphing wise, or maybe you think it's slow, but you should probably even go slower than me because you really need to be thinking about every like move that you're making. Let's try another. Let's say, for example, we have f of x equals x squared, parenthesis x minus 2, x plus 2 squared. Okay, let's get our X and Y axis going. And then let's say our X-intercepts or our zeros first. So the first one I notice is we have one at 0 with multiplicity of 2, which means I bounce. The next one I notice right here is 2 with an exponent of 1, so no multiplicity because 1 is just 1, there's not multiples, so that's a cross. And then the last one I notice is negative 2. That one also has multiplicity of 2, which means it'll bounce. Okay, so we can plot those. We got 0, we got 2, and we got negative 2. There are no other spots that you will be touching on that x-axis. That's it. Next thing we got to think about is that end behavior. Oh my goodness. End behavior. Sheesh. So I'm just going to think about my cloud. And because when I add up my exponents, I got 2, 3, 4, 5. I am odd. Because we're positive, we are like a positive sloping line. So like this. So when I start my graph, I have to start past that first x-intercept down here. And when I get to negative 2, I got to bounce off of it. So I have to do like a little baby parabola off that. I'm not going through, I'm just bouncing right off of it. The trouble is I have to get back up to here. So I'm going to have to like do another hump down below. And at 0, oh my gosh, I need to bounce off of it again. Okay. So I'm going to come back down, but I have to get back up here. So I'm going to have to turn around again. And at 2, I'm going to cross right through. And I'm not going to come back down because there's no other x-intercepts for me to touch. So I'm hoping that I was supposed to end up, and I sure was. Let's try one more. We have f of x equals negative x plus 3 to the third, x minus 2 squared. Okay, let's get our x and y. I have a 0 at negative 3. There is not one here for 0. Like if there's no x up here, then there is no x equals 0, 0. So there's one at negative 3, and it has multiplicity of 3, which means we are going to wiggle. I also have one at 2 with multiplicity of 2, so we are going to bounce. When I think about my end behavior, because I have multiplicity of 3 and 2, that's a total of 5, so we are odd. And because we are negative, we are like a negative sloping line, so like this. So I'm going to plot my negative 3. I'm going to plot my 2. Those are the only 2 spots that I can touch on this entire x-axis. I have to start up here. And when I get to negative 3, I'm going to wiggle. So it's like I'm going to do a parabola, but then I change my mind. Now the thing is I have to get back up to here, so I'm going to have to like turn around and do like a hump down here. And when we get to 2, we're going to bounce. So we're going to bounce right off that. And I'm never going to come back up because my x-axis doesn't have any more dots on it. And so we're going to end down, which is hopefully what we were supposed to do. Heck yeah, it was. Okay. We're going to practice so much more tomorrow too, guys, but try your best for tonight.